Guys, the last dot point here I'm going to do a video on is for assessing the methods of effectiveness of rehabilitation at a contaminated site. So we depend on minerals that are extracted from the ground to produce everyday commodities. To minimize environmental effects of mining, alternate products have been invented, more efficient means of production have been developed, and recycling levels have increased. Rehabilitating the mine site is also now mandatory for mining organisations. Careful managed rehabilitation programs are put into action to help restore the area to its original or similar state, to basically restore it, and sometimes it may be converted into recreational or residential areas. Why do you think this is important? Mining companies spend a lot of money ensuring rehabilitation regulations are met and often exceeded. The basic procedures mining companies follow are listed below: exploration and discovery of the mineral, community consultation, develop environmental impact statement, seek approval from state government, establish animal shelters, seed collection, topsoil removal and storage to ensure successful rehabilitation, mining, replace topsoil, reshape landforms and plant seeds that are collected earlier, and final rehabilitation of mine back to previous land use or modified new productive land use. Mining rehabilitation often involves filling holes that are excavated, putting back the topsoil, and trying to keep the original contours of the land, and often revegetating the area of the right mixture of the species that existed before, including the native flora and the native fauna as well. So as you can see, a lot of work goes into rehabilitation programs, and it occurs during the entire duration of the program and afterwards and before. In the early days of mining in Australia, there was no such thing as rehabilitation. Mining took place with little to no regard for the environment, and once the mining was complete, the site was deserted. What are some of the problems this would have resulted in for the environment? Have a think about how abiotic and biotic factors affect an ecosystem. Some of these old mines are now being rehabilitated, and governments now require rehabilitation methods to be planned prior to mining. And for this dot point, we have in our worksheet about the Peelwood site, and you can go through, you can do some extra research on your own, make sure that you use credible sources to answer the questions and assess how effective they have been. So we need to know how much has the rehabilitation program actually tried to rejuvenate the land back to how it was before, and how do we know that? Another example here is and the Mary Kathleen mine, and I'm going to go through this, and this is, if you don't want to do the Peelwood one, you can do your own research and choose this one here. So we've got a uranium mine here located between Mount Isa and Cloncurry, northern Queensland. It operated between 1958 and 1982. Okay, so basically we have obviously a uranium mine. Uranium was becoming a really important source for energy production, as we know, for nuclear power. You can have a look. Australia is one of the places where we have lots of resource for a lot of different things, especially energy production. So how was Mary Kathleen contaminated? Tailings from the mine were dumped in a dam that overflowed into an evaporation pond 60 hectares inside. The potential for seepage of tailings was considered and addressed. Waste from the mine was radioactive and thus considered contaminated. This was also addressed. Following the closure of the uranium mine, a rehabilitation plan was implemented. It aimed to make all areas safe for public access, remove all unsafe structures, and encourage natural vegetation on erosion-resistant surfaces. And you can come and see me for the report if you wish to have a copy of that and if you wish to do this, this mine. We've got some images. It was obviously an open pit mine here. What methods were used? Contaminated liquids from mining operations were contained in evaporation ponds, where they were treated to remove contaminants. The remaining contaminated slime and soils were sent to the tailings dam and buried with the contaminated soils and equipment from the mine site. Contaminated soils were buried under a layer of clay and covered by waste rock. The clay-soil mixture greatly reduced the release of radon gas, and the waste rock provided erosion control to prevent the leaching of radioactive materials from the tailings dam. The creek diversion was maintained to minimize erosion of the rehabilitated tailings area. A filter zone was constructed beyond the buried material to trap any fine particles carried from the tailings material. Evaporation ponds had remaining liquids pumped back up to the mine pit. Vegetation was re-established in the area using the same plants that existed in the nearby environment to support existing ecosystems. And this is the difference between 1976 and 1988. You can read this report if you choose to do this one. While the project was probably a success with respect to its aim, recent studies into the contaminant dispersion highlight the need to evaluate rehab success after some time has passed and to study the environmental impacts in detail. Okay, and this is the type of HSC question you may get for this dot point. You would a mine was worked for about 80 years to produce silver, lead, gold, and some copper. Extensive environmental damage has been caused by the unused rock from the mine shafts and waste from the processed ore, both of which were dumped in large piles. Outline 2 environmental problems that could have resulted from the mining activities and give 1 solution for each of these problems. So what you have to do here, each one is worth 1 mark. Outline means to roughly sketch. So you could pick any of these problems that were mentioned, including the fact that the tailings were dumped into a pond and the waste from the mine was radioactive and contaminated. So there was contamination and there were different methods that were used to try and minimize that. So that's a part of assessing, right? It's not the entire assessing, but it doesn't mean that they cannot ask you a question that is either identify, describe, explain, discuss, all the way up to assess. So as you know, your alarm scaffold is like a step ladder. They can, your matrix, sorry, not scaffold, your alarm matrix. And so it is like a step ladder. So at the point of assess, it's pretty much one of our highest ones, along there with evaluate and analyze. Those 3 words are the biggest ones. Justify can be too, of course, but not when it's something like justify your decision when it comes to predicting something. That's going to be worth 1 mark. But if you're asked to justify the following statement, you will need to provide evidence by naming and describing the relevant components. But here, all you're doing is outlining and giving an example. One thing is that even though you may think, oh, it's just outline, I'll just like roughly sketch and then it just says name, I'll just write a word in there. If there are other people who have also written an answer, Band 6 will be decided based on a comparison of all other people's Band 6s. So the more you can elaborate on your answer, not by explaining or discussing, but actually just describing the solution, the more the reader will understand your answer and the more likely you are to get a higher band. And I think that's what we found looking at different examples of what other students have written to achieve the bands that they have. Alright guys, that's the end of this module and the unit caring for the country.